AI workshop. So today we're going to unpack a couple of the fundamentals of AI and machine learning. So what we've decided to do, we've been asked a couple of times by our customers and our potential customers, how do we unpack this AI revolution and how do we make it more tangible to people that don't understand it? Obviously, it's like some people think it's a dark art, some people think it's something that's going to change the world, and obviously it contains all of those different angles. So today we're going to just have a workshop around this. What I'm asking you guys to do, it's interactive. So after every speaker, there's an opportunity to then basically have a question and answer. So you're welcome to answer the guys. So if you have any questions and you'd like to know any more information, you're more than welcome to ask that. On a second front is after the session, we'll be available for anybody to chat about the different principles and how that we can help you in your AI journey. So firstly, so my name is Sean Winterburn. Sorry about that. It's a little bit late. I'm the CEO of OQLIS. And my responsibility is to evangelize AI within the market and make sure that we give out the right message and make sure that people understand this technology properly. So today is really about unpacking that so that people can get a good feeling. It's about education. It's about asking questions and really going that extra mile and understanding what is pretty much the unknown in the market. So the first person that I'd like to introduce is Raluca. So a veteran of innovation in this market. You can see she has quite a lot of, well, let me just go through a CV. So firstly, she's a Technology Innovation Manager, CEO for Global Institute of Accelerated Innovation. She has a master's degree in IT engineering. She has a postgraduate degree in theory of change at Stanford, and really she's a true innovator in the market. So I'd just like to welcome her and enjoy the time with her. Thank you very much, everybody.
Good morning. Thank you for coming here. I'm very much passionate about innovation and about artificial intelligence. That is one of the possibilities to innovate, to create solutions to problems that are around us. So I'll also connect you to Professor Melanie Mitchell from Santa Fe. She has a clip for us to a kind of support, and she will talk to us about artificial intelligence, AI, unsolved problems. So she will come after me in a clip. Now in San Francisco is around 1 o'clock in the night. She couldn't participate in her person. She sent me the clip. So my presentation is starting with the definition of what is it AI, some kind of thoughts about it, why we need, when we strategically start something, if you are beginners in this field or you want to continue, we have to have a basic in this discussion. So artificial intelligence is part of computer science. And like you see here is a joke. The CEO of AI Foundation sees us that very soon everybody will have a digital twin to talk to. In the morning, you give him the list, the twin will solve out your problems. So from this point of view, there are hundreds of pages in internet if you want to see the definition of AI. Even I myself try to put a definition. So it's about creating machines that have intelligence. They learn from data. They learn to achieve specific goals, and they want to respond to them in a flexible adaptation way. So it's the field of computer science where the goal of the scientists, of researchers, is to equip machines with human intelligence. I said human and intelligence and artificial. There are so many terms that are very blurred to define. It's not easy to define. For this reason, there are a lot of debates around these definitions. So artificial intelligence has many applications in cognitive systems, cognitive science, in robotics, and natural interfaces applications. In cognitive science, we started in 1966, 1970 with expert systems, yes, learning systems, fuzzy logic, using genetic algorithms, but also we created intelligent agents like Alexa and Siri. Robotics, in robotics there are many ways to interfere with the environment, to sense the environment. In order to have a good robot, the robots must have a double-way communication with the environment. Natural interface applications, natural languages, speech recognition, and so on, virtual reality. So what we are talking about, the fundamentals of artificial intelligence is to analyze data. After you collect data properly, only correct and good data can create valuable output. So it's about big data. It's about to learn from data using specific algorithms. There are many algorithms. So, and after it, to build your solution, because you look for a spatial solution. The solution must be unique. In other words, why you invest so much time and money if the solution is not unique? So practically, artificial intelligence, AI, creates a lot of innovation around. So this is the history of AI. What is 1956? John McCarthy, the professor from Stanford, he named this field of trying to create intelligent machines. He named it artificial intelligence. Why? Because he wanted to make a difference from other fields like cybernetics, information technology, and so on. So they started very enthusiastic. They received from Rockefeller a lot of funds. But not only him, also Marvin Minsky. At a certain moment in 1970, he was very pessimistic. He wrote an article that he doesn't feel the machine will ever be intelligent. So for this reason, they had a very big backlog we call winter. James Lighthill, a professor, a British professor, said, finish with this investment, stop investing in this, is rubbish, never ever will have intelligent machines. So the winter came and a lot of investment was stopped and research. But still, Japanese were still investing, and you see they are very good in robotics now. Now they started to look in what the machine can do, how they can prove AI is meaningful, has a value. 1997, who knows? 1997 is the moment when Deep Blue software programmed specially to play chess was defeating the Garry Kasparov world champion, 1997. After it came IBM. You know, IBM developed Watson, and they won Jeopardy, $1 million. But this is not easy, guys, and these are expert systems. They are not intelligent systems. I'll explain you later why. So they worked 7 years for this Jeopardy, a team of researchers and developers in IBM. IBM was dedicating, of course, for marketing reasons to explain how powerful they are and so on. So 2015, AlphaGo, yes, DeepMind. The company that is in partnership with Google, they won the game, the software application won in front of a world champion in Go. So a big achievement, because it's much more difficult to play Go than to play chess. I know chess, I don't know Go, but they said so. So I believe it. So they said the first movement the computer did, it was so strange that nobody believed this kind of movement can create a winning moment at the end. But they managed to win. 2017, it's a very interesting year. It's a turning point where new algorithms, deep learning, and other kind of algorithms I'll explain to you came in the market to create fantastic developments for AI, for problem solving and so on. We are in 2022. I know, probably you know about the development in speech recognition, natural processing languages, transformers from OpenAI. If you didn't hear that, it will be presented here. So we are in this moment in a very exciting situation where AI has an impact in business, in social development, in creativity. AI is capable in this moment to mimic perfectly the great musicians, classic musicians. AI can write music similar with these musicians, Chopin or whatever. If you put a musician to specialists to recognize if it's Chopin or the computer, they make mistakes. So good they are, it's absolutely scaring. Yes? So more or less you see ups and downs. From naive algorithms to swarm deep reinforcement learning. It's about learning in this artificial intelligence. So we started to repeat first, to imitate. We started to learn in 2010, 2018, and we are in 2022. We are talking about distributed agents, software entities that can do by their own tasks. They can create, they can be creative, they can do a lot of things that we, the developers, want them to do. Very intelligent, so kind of intelligent. Now, of course, AI has many classifications. No? Based on capability, we talk about narrow AI. We are in narrow AI. We are not yet in general AI and super. Narrow means doesn't do things that are so-called intelligent, doesn't mimic perfectly human intelligence, but has some limited memory where the computer can save what it learned before, and the computer can also after saving, can use its experience from this learning to produce better results. So it's a continuous situation where we are now in this moment in narrow AI. General AI and super AI, not yet. Now, based on functionalities, reactive machines like Google search, email spam, Watson, they are reactive machines. They don't memorize what they find out. Yes? Good morning.
I would like to ask, how do we get to general AI as we are not yet there?
The researchers are busy with it. There are many problems. I'll show you problems in trying to reach general AI. We don't have yet a theory of mind or a 100% cognitive theory to understand the mind. For this reason, not understanding very well, and we are not yet capable to understand human emotions. So we work only with physical sensors that can feel physical measurements, not emotional measurements. But is it good or not? This is another discussion. Is it good to have general AI, somebody or something that is more intelligent than us? This is a big question because, yes, reactive machines, limited memory, we are now here in limited memory functionalities. Theory of mind and self-awareness functionalities is not yet developed. They are busy, very much investment. Microsoft invested $1 billion for general AI. Fujitsu created a big, let me show you down. So these are intelligent agents, yes? Part of the limited memory and part of the, you see, they don't react to emotions. You can scream at Siri or Alexa, they don't care. You can scream. Okay. So super AI can perform any task. They are more intelligent. So how do you negotiate with somebody more intelligent than you? So this is another discussion. It's a little bit where. This is the Fujitsu, can you believe it? It's in a sport hall. They invested so much to create this infrastructure and simulate one neuron, one human neuron, in 40 minutes of this computer power. Yes? And these are the Chinese, the Defense Department, National University for Defense Technology. Look what they did. It's one exaflop. A flop is a cycle. And it's something quadrillions of cycles per second. Something very, very, they invested in it, hoping that they will reach the general AI. Yes? So the investment is not stopping. So AI is not only about algorithms, it's about data. But data science is not only part of AI. For this reason, I put an intersection between artificial intelligence, machine learning, deep learning, and data. Yes, not everything is data science belongs to AI. There are statistics and other science fields that are using data. So these are the subsets of artificial intelligence. Now, we are talking about artificial neural networks that are a discovery from end of 1940, 1950, and they come again after 2000, that are using training and inference. I don't want to lose your time because professor is eating from my time around 15 minutes, so I'm going to be faster here. But who wants to study? It's just for your information. To study and see what is it, we can talk. It's a fantastic development on deep learning, especially used in image recognition and in speech recognition, will grow like 30% over the next 5 years. So it's, yes?
So I would like to ask, like machine learning, the deep learning, and artificial neural networks, they fall under artificial intelligence.
Yes.
So what differentiates them? Is it that one person has to choose which algorithm works better for him?
Of course, it's depending on what problem you want to solve. Okay. Deep learning is more when you try to recognize images, image recognition or speech recognition, because they use many hidden layers. For example, the transformers are using more than 200, 300 layers, hidden layers of classification, of dividing the data in segments that the computer, the software can recognize. Machine learning can be supervised, unsupervised, or reinforced. Supervised when the developer is in the back of the computer and looks what's happening. Unsupervised is when it's let by itself analyzing the data, and you see there are many errors there. You see the output, and you analyze the output, and you come back to sort it out, you the developer. Reinforcement learning, when you try to give incentives to the computer. When the computer is, the software, AI software is working well or is not working well, you give incentives. It's not very easy to explain now, complicated, but it's like in training in schools. When you give children incentives, they learn better and they forget about mistakes. They don't do mistakes anymore. So this is the way it's looking like a deep neural network, many hidden layers. Yes, the input data that is describing, for example, a number 9. Yes?
Sorry, I didn't get the you said for neural networks.
Yes. This is deep neural networks. This is an image, an abstraction, of course, a graphic showing you how many layers of data that you, for example, you want to read number 9. If you want to read the computer to read number 9, you input 9, but you divide 9 in many segments. Yes? And you continue to divide this 9 until the computer recognizes or not that number. When you see didn't recognize the number, means that your software, your algorithm is wrong, and you go back and do corrections to your algorithm. Very simple. Who knows? Sorry, I'm losing my time, but it's not for, just to put you in the framework. Yes? So now we are talking about big achievements of a company called OpenAI. Elon Musk is co-founder of this company. And it's amazing. It's the GPT-3 transformer is the one that Google engineer said it's a ghost inside the computer. Did you read about it? No? This recently, in 2022, an engineer from Google said, it's a ghost inside. It's so clever. We reached super intelligence. They said so. I don't think so. I was watching many. You can go to YouTube in internet and just Google and see GPT-3 dialogues of humans with this machine, and what do you think about it? It's not yet super intelligent, but it's very, very interesting how the computer answered. Now what the impact is, we are scared of jobs. The AI will replace us, the software. We are innovating differently using AI, you know. Who is innovating? The software, the machine, or you? Strongly, I believe that we innovate, guys. It's a story, yes, it's to make a little bit of advertising for ourselves. No, we are on the base of all this development. Nobody can tell us, we humans, we are stupid because now it's a super intelligence that works better than us. We created it. You know, like you have kids and they are cleverer than you. You have to debate about it. It's very important in decision making because the CEOs can use AI for decision, can use a lot of input. They can decide, no, AI machine will tell me what to do. I'm not interested I'm following what AI is saying to me or not. I just use AI to empower me. So all the questions at the end, I'm very sorry. I'm very happy you have questions because it's very good to have. So we can obtain business growth using AI. This is the impact that everybody is interested in business, yes? So, but we don't have regulations with this AI. It's supposed to be an iOS this year to start to write policies and regulations. I don't know if they started, but we have to be very prudent because I'll show you other problems. Now we start with problems. We have to be realistic, not only enthusiastic about AI. Yeah? Realistic is that there are problems. So there are people, adversaries, competition that try not to make AI working. So if you include in your image some pixels, extra pixels from a lion, practically you transform the image in a, what can I say, in a car. And the computer says it's 99% accurate. So a little bit of distortion of the data, of the input, creates big problems in the output. Data is very important to collect it properly, to be integer, to be data that doesn't have faults. So the data scientist is extremely important in developing good applications in AI. So deep neural networks are easy fooled. Yes, you can easily fool. If you drive a self-driving car, not drive, if you use a self-driving car, and on the traffic sign somebody puts some spots, some color on a stop sign, the computer doesn't recognize anymore the sign, and you can have an accident. More problems. It's about the computer power. It's very expensive. Yes, you see the gigantic infrastructure where Fujitsu or the Chinese are investing to obtain general intelligence. And from picture, it's saying different 89 to 79% different responses. Cannot recognize the original clean images completely with 2-3 pixels difference. Yes. Attacks in medical field of adversaries who attack the data. You take the data on input, yes, for medical reports, asthma, and can have an attack. And the other one last year I studied, and I built the prototype for an LPG consumption and safety software application using AI, using data. So this is ProAsm using the speakers of the cell phone and the data from the patient, connecting to the doctor reports and information for the patient. And it's a full, it's just schematic here. It's a full story how I use the data to make aware the patient 24 hours or 48 hours before the asthma attack. Okay? This is health I bought. 10 days ago, Geneva phoned me and they said, you got the award for IP. I worked with a group of doctors from Ireland. We are together co-innovators in it. And finally, we got the IP. And this one also is embedded with a lot of artificial intelligence libraries, machine learning libraries. The problem is here in medical is who owns the data. You know, it's a question of data privacy. I used I used a very good cloud platform that is changing only very little number of bits, so it will not be very costly. And this is the LPG, one sensor. With one sensor, I can research all the data for supply chain and for safety reasons. LPGs, you know, for keeping the gas in. So in conclusion, in 2030, we have 13 trillion return to the global economy done by artificial intelligence. You can't just ignore it or say it's difficult or I don't have an application to use artificial. No, you have applications. If you want to go further, you are interested to go further, we are going to talk to you one-to-one. You phone us and we are going to explain where can you use artificial intelligence. Even in marital situations when the couples are fighting, now it's a bot, it's an application, mobile application, then start to sort out between the members of the couples. So emotional. Now I want please to start the Professor Melanie Mitchell presentation. It will be very interesting because of this I told you everything here. What she is doing, she's a David professor and she was so kind to give us her thoughts. The clip is made, be careful because in the clip is something very funny.
Hello, my name is Melanie Mitchell. I'm happy to be able to say a few words to you today, and I'm sorry I couldn't join you in person. I'm going to say a few things about my thoughts on the current state and future of artificial intelligence. Let me share my screen. So many of you are aware of the recent deep learning revolution, which has really changed the field of AI in very significant ways. Most deep learning systems are roughly analogous to the visual system in the brain, in which we have a number of different layers of neurons that process information and feed information forward between the layers. This is the inspiration for deep convolutional neural networks, or convnets, which take an input and then process that input through a series of different layers to finally have an output in which there is a prediction for, say, what the image is. And here you can see the prediction is that the image is of a boat. Well, because of the scale of data on the internet and the rapid improvements in computing, in the last decade, companies and other research institutions have been able to obtain huge amounts of labeled data, like in the form of images. This is a picture of the ImageNet competition's kind of labeled data of different image objects and images. And this availability of data and compute power has really revolutionized the performance of many AI domains like computer vision, object recognition, where you can see over the years of the ImageNet object recognition competition, different error rates of the best entry have gone down until they're lower than the approximated human performance on this task. And this has made its way into the commercial world with tasks like facial recognition. Say Facebook can now tag you in an image using one of these kinds of neural networks. And self-driving cars, which are able to now identify different objects relevant to driving on the road using these kinds of deep neural networks. Deep neural networks also play a large role in things like AlphaGo, the program that was able to defeat one of the world's best Go players. And in language generation, this is a picture of the interface for OpenAI's GPT-3 system, which is trained on huge amounts of English text gotten from the internet and also digitized books and other sources. So I actually asked OpenAI GPT-3 a few questions. First of all, I asked it, what will be discussed at the AI Tools and Technologies virtual workshop in South Africa, especially for you? And it replied, the purpose of the AI Tools and Technologies virtual workshop is to provide a platform for experts and practitioners to share their knowledge and experience on AI tools and technologies and to discuss AI development in South Africa. Well, that sounds like it could be a blurb. That's what GPT-3 came up with. Then I asked it, what kinds of refreshments will be served? I don't even know the answer to that one, but it says that refreshments will not be served. Why not? It's a virtual workshop. Well, its reasoning is that if this is a virtual workshop, which I told it, I told it in the initial prompt, its reasoning is that such a workshop, there are no refreshments. You can tell me whether that's true or not. But the question is, for all of these systems, they're very large neural networks, but yet very opaque. What exactly did they learn? And often the answer is somewhat surprising. As an example, one of my graduate students did an experiment where he trained a deep neural network to distinguish photos with animals in them from photos in which there is no animal. And it did very well in this task, but when he looked under the hood and tried to understand what features of the image the neural network was making its decisions on, he found that it had learned that if the background is blurry, then the image is likely to have an animal, because of course the photographer has focused on the animal in the foreground. Whereas if there's no animal, the photos were usually these kinds of landscape photos and the background was clear. So the system is using what's called a shortcut. That is a relatively simple set of cues that are not what the human intended for the system to learn, but which actually enable it to perform the task, at least on the data set that it's trained on. But such systems have trouble often generalizing, say, to photos of animals in which the background is not blurry. Another example of this was a study done by a group in which they entitled the paper, "Neural Networks Are Easily Fooled by Strange Poses of Familiar Objects." So they took a neural network that was almost 100% confident that this is a fire truck, very good. But if they photoshopped the object into some unusual pose that the system had not seen in its training data, it now was fooled into thinking that there was a school bus with 98% confidence, or a fireboat, or a bobsled. And they were able to show this with many different objects. So somehow these neural networks are relying on some features of the image that are not the same ones that humans rely on, and may end up limiting the neural network's ability to generalize robustly. And we can see some not very non-robust abilities here in this Tesla that was on its autopilot software, and it crashed on the highway into a stopped fire truck that was at a weird pose, as you can see. Even these language generating programs can fail in very unpredictable ways. You know, I showed you some impressive performance, but many people have documented how these systems don't really understand in any human-like way what they're talking about. And so they can make very unhuman-like errors. Some people have made an analogy between Clever Hans, who was a German horse at the turn of I think the 19th century, who supposedly was able to do arithmetic. And Clever Hans was taken around Europe showing off its skills. It would be asked an arithmetical question like, what is 24 plus 32? And it would beat its hoofs a number of times. And that signified the answer. But it turned out that Clever Hans was not doing arithmetic at all. It did not understand arithmetic, but it was responding to subtle cues in the body language of its trainer. And the idea here is that somehow these neural networks have learned vast amounts of information and statistics about that information that give them sort of these kinds of subtle statistical clues about what to do and how to predict something or how to classify something. But they're not doing it in the same way that humans do it. They're doing it using some kind of statistical correlations that we may not even perceive. It's been shown, of course, that deep neural networks are susceptible to adversarial attacks, where an attacker, say a human engineer, can produce subtle changes in the pixels by adding in some random looking noise that will cause a neural network that's very confident on the correct answer to now answer that this is an ostrich in every case. This is something that can be done quite fairly easily for many computer vision neural networks if you have the right kinds of computational tools and the right kind of knowledge about the network. But it's been shown that even in the real world, you can take, for instance, stickers cleverly positioned on a stop sign and fool a deep neural network into thinking that this says speed limit 80, a little bit terrifying. So I wrote a paper about all of these kinds of issues called Why AI is Harder Than We Think. And I talked about why some people are what I think is over optimistic about the prospects for human level AI in the near future. One of the fallacies that I talked about was something that the philosopher Hubert Dreyfus mentioned, that he noticed that what he called the unexpected obstacle in the assumed continuum of AI progress has always been the problem of common sense. Of course, many people are putting a lot of money into teaching computers common sense, including the United States Defense Department, trying to get through this barrier of common sense that machines seem to fail to cross. So in my book about AI, I talk about this figure. When you see this kind of situation, you make up a whole story in your head. You understand what's going on. You see a distracted pedestrian or a woman who's talking on her cell phone, and she has a lot of things going on. She's pushing a stroller and she has a dog, and you understand why the dog is sniffing down here, and you understand that people cross the street and may not know each other, and all kinds of vast knowledge about the world that you bring to bear when you're faced with situations like this. Well, this is something that computers lack, this kind of common sense knowledge about the world that might have a self-driving car, for example, not quite know what to do in this kind of situation. So what would it take for a computer to understand this image? Well, some of the core components of human understanding are things like having the intuitive physics knowledge that we have about how objects move and how they interact, the intuitive biology and psychology about animals and humans, and that allows us to predict their likely next behavior. Being able to have mental models of cause and effect, this vast world knowledge that I was talking about, and also the ability to abstract. I called this a distracted pedestrian situation. So I can recognize its similarity to many other kinds of situations, even though they're superficially quite different. And those kinds of analogies allow me to take knowledge that I've learned in one situation and apply it quite flexibly to other situations. So these are all the main challenges of AI today. I think that they are going to be harder than many people think to solve, but that's really an open question. So thanks for listening. I talk a lot more about this in my book, and I hope you have enjoyed this conference. Goodbye.
This is the book, one of the books. She was winning a big prize in 2009 about a book called Complexity. And this book, we are prepared to give 3 books like this, but I have to put a question to you. Who is going to answer? Please use the pen and paper. And who is coming, the 3 coming to me to give me the paper with the correct answer. Tell me in what year Alan Turing built his, discuss about the test, the Turing test. What is the year? Year, yes, year. When Alan Turing, a Cambridge mathematician, yes. No, don't cheat. Don't cheat. You are a hacker. You come quickly. You are honest. Yes. Who? 3. I put a very, very easy question.
I can tell you about this test. I can't tell you what you.
Okay, 3 people. You don't own the book. Okay. You want so Grant?
Yeah, they say I mustn't move so far away. Get too excited walking around. So, yeah, thank you, Raluca, for that lovely introduction to the industry as itself. And the next speaker is Professor Johan Steyn. So he's an AI thought leader. Professor, I'm going to just get it right here, is at the Waxen, how do you say that? Waxen?
Waxen.
Waxen University of Research and a fellow at the Stellenbosch University. He's formerly from Accenture and currently has a business called AI for Business. He's a thought leader and he brings a different spin to the whole AI environment. He looks at it from the good side and what's the possibilities for good. So, Johan, thank you very much for joining us, and let's do this thing.
Thank you. Thanks, Sean. Good morning, everyone. Good morning. It's good to see you. There are a number of things that we cannot automate with software. Any shout outs? What can you not automate with AI or software or anything like that?
My wife.
Your wife? Okay. Can you automate experience?
No.
You can't.
Non-repetitive stuff.
Yeah, that you can, of course. Oh, sorry, repetitive tasks. You what you're saying. Sorry. Cool. There's a hand. Yes.
Human emotions.
Human emotion. Very good. What else? Say again. Eating. Eating food. Well, unless you have a robot that you still have to digest it, but you can have a robot that maybe feeds you. Okay. So you definitely, obviously, you can't automate intuition, human experience. And the one thing I love telling a lot of the clients I deal with, tongue in cheek, and they don't like to hear it because they do it every day, you cannot automate stupidity, okay? A lot of the AI and automation implementations that I've worked on with customers, I have been astounded by what people think they can and cannot do with this technology. So I often say, and it sounds so simple and so common sense, automate the right things in the right way and for the right reasons. So when I play against an AI, chess or Go that we've just seen, and it's going to win. Of course it's going to win because it's 100,000 times smarter than I am. But do you think it knows that it's winning? Do you think it celebrates that it won? Why not? Consciousness is something we have, which is even today difficult to explain. Awareness, self-awareness, something that differentiates me as a Homo sapien from other primates or other mammals, or as far as we know, any other being on the planet. I am aware of me. Unlike animals, I don't live just out of a fight or flight instinct. Although when you go to a rugby game at Loftus, then you think you're surrounded by, not because it's, but sport brings out that most primal thing out of us. So does natural disasters. But I am aware of me. I feel sadness, I have hopes and dreams, I experience joy, and what mainly differentiates other animals is the fact that I can imagine the future and I can remember the past. The problem with remembering the past for us is that it leads to regrets. The great challenge about imagining the future is that it mostly leads to fear. But I know I'm going to be here tomorrow. Well, hopefully it would. But I'm not, I've got this sense of awareness, of course, and some mammals are evolved, like elephants or dolphins, for instance. But we are much, much different. And the challenge that we're facing, which leads me to the conversation, is will where this technology is going fundamentally change what it means to be Homo sapien? And are we, like a lot of authors like Johan are claiming, are we potentially creating another species? About 50 or 60,000 years ago, humans, Homo being. The challenge is we are creating it through this technology. So what if half my body is 3D printed? Am I still human? Most likely, because of the economy. And then there's also, again, creativity. And the people who really make money are those who can jump on the bandwagon at the right time and who don't fall on the destruction side. The problem is most people on Earth are greatly impacted by the destructive cycles, job losses. You don't have $1 million somewhere to cover you through you don't have generational wealth maybe and stuff like that. So Conductive came up with this model, these different to what we call the first, second, third and fourth industrial revolution. There's some sort of technological innovation that triggers a new cycle. So it could be steam and horsepower and all those kind of things. By the way, in South Africa, in which industrial revolution are we at the moment? Who knows? It's supposed to be the fourth. The second, why? Because electricity supply became mainstream in the second industrial revolution. Okay, now really think of it. We talk about 4IR commissions and stuff, and government is doing some things. I mean, we had this October, 2 years ago, we had the Presidential Commission on the Fourth Industrial Revolution. Phenomenal piece of work. None of their 8, I think it was 8 recommendations have been implemented yet, because we're struggling to supply electricity. We're struggling to feed people. The trick for us all, that society, government, business, all of us together is, how do we look at the real problems that most people in our country are facing right now, while at the same time innovate through technology. A lot of schools are now talking about robotics and coding, which is good. We should have done it a few years ago already. Hungry kids don't learn, because we have some serious societal issues. My sister is a teacher and a social worker at a school here in Danville in the west of Pretoria, a very poor area. Most of those kids have their one and only meal per day at school. I can't even imagine what they went through during some of those hard lockdown periods. How do we teach those kids to code when they're hungry, when they live in homes where there's gender-based violence, and so forth? You know, so that we're dealing with some serious issues. And we have to think about it. We've got very unique opportunities in this country to utilize this technology, not just for wealth creation, but also for societal good, especially in education and in healthcare. We would today have been in what Conductive would have called the 6th wave. All right, so we are most likely on an upturn again, empowered by technology. The challenge with the so-called industrial revolutions, because I think it's a very narrow way to talk about it, is because people will say, don't worry, in every industrial revolution we managed to eventually create more jobs than were lost, which is true for all the previous industrial revolutions. There's always a massive upheaval because you were a horse cart rider and now you need to learn how to drive a locomotive or something like that. The problem with this industrial revolution is it's changing so rapidly that the chance of continually upskilling yourself, because it's no longer once or twice in your career you pivot. You were an accountant, or you were a plumber, now you're becoming an accountant because you did some studying at night or whatever. Especially all of us here, and I assume most of us, if not all, work in what we call knowledge work. Our jobs are highly automatable. So what do we do as individuals to constantly keep on learning, reading, watching videos, speaking with people? The point I'm just making is you can't just sit still thinking, I'm a CA, I'm okay, because you're not okay. Or I'm a whatever. In fact, if you work with your hands, if you